Sorry, the screensaver went on again. I should fix that, but we'll just power through the rest of this. So yeah, we have our initial set now set up, and to pick a biform, let's pick A for now. So we have in our initial set we have A and A complement, so we can pick that as our biform. And then if you recall our residuals, so we're going to have A and A complement. Our residuals are just the elements in our initial set with the biform, the appropriate biform removed. So we're going to have for our A biform, our normal biform, what are the sets that contain A? Well, we have A, B, C. That doesn't contain A. That doesn't contain A, but CA certainly contains A. So if we have ABC without A, that's just going to be BC. If we have C bar A without A, that's just going to be C bar. Sorry, I didn't write the C. If we have, now we go on to our complementary residual. So we have ABC that doesn't have A bar, but A bar B certainly does. And neither of these have an A bar in them, so A bar B without its complement, without A bar, is just B, right? So we see here that that these are our residuals, and we get our new consensi by just doing element-wise kind of multiplication on this. So if there was like another term here, we would go here to here, here to here, then here to here, or here to here. But I guess what we're really doing is forming a set with a hammer-and operator, I think it would be called, or in MATLAB they call it element-wise multiplication. No, not quite element-wise. There's a name for this operation, but I really forget what it is. There's something like this we did in linear algebra. But BC times B is just going to be BC, right? You recall that that's from the property A times A equals A, right? And then C bar times B is just going to be B C bar, right? And now the final set here is going to be the union of this new consensi column and this initial set column. So we can write it out. See, Dr. Keshavarz does a shortcut, and his shortcut on this problem gives him like 6 steps. And you know, I don't quite understand his shortcut and what he's doing. And you know, in my humble opinion, if you don't understand a shortcut, then you shouldn't use it. I don't think you should do things you don't understand in the first place, or at least, you know, try and understand what you're doing. So we have our final set, but we need to simplify this first, right? And this is fairly straightforward to do. This BC plus BC bar, this is going to work out to, we can factor out the B and get C plus C bar. That's just going to be identity. So now we have A, B, C plus so on. Right? And now what we can do is we can move this B term over here. We get equals A, B, C plus A bar B plus B plus, when I say plus, I'm meaning or B bar C or C bar A. And we can factor out the B from these 3 terms here. Equals B times AC plus A bar plus 1, or identity, plus B bar C plus C bar A. Now, whenever you have an expression like this, where you have a 1 with the OR operation, this is going to just reduce to the identity. I can just prove this here. If I have the term, let's see, a b plus a c, and I factor out the a. Plus a, yeah, a, and it's b plus 1, b or 1. If I make it a truth table for b here, and then 1 is always going to be 1. This is kind of abusive notation for b, but b is 1 is 1 obviously. We have b or 1. Well, 0 or 1 is going to be 1, and 1 or 1 is going to be 1. So we see that we have this reduces to just identity. We just have a equals a b plus a. I think they call this the absorption law. So we can see here we have a bunch of OR-connected terms. We have this whole OR-connected term connected with this 1 here. So no matter what, all these terms, if we had a million terms here, because we're ORing it by 1, we know it's always going to be 1 because anything OR 1 always equals 1. So this whole thing just reduces to identity. And we get the set B or B bar C or C bar A. Okay, and we can. This is going to be our final set. If you screw up with your factoring or your simplification, it doesn't matter because it'll eventually just all work out. You might have more steps, definitely, but you'll eventually get to the right answer. So for example, if I only did this step and then didn't do all this other stuff, I'd still get the same answer eventually, but it's just going to take more steps. So we just copy over here that our final set is going to be B and B bar C and C bar A. And that's going to be our first step, okay? We just draw a nice horizontal line to indicate that. And now for our initial set, for our next step, our next biform variable is going to be the final set from the previous one. So it's going to be B and B bar C and C bar A, right? And our biform here, let's just go ahead and pick B. It doesn't have to be B, it could be C, but you know, I'm a bit OCD and I like everything being consecutive and things like this. Of course, our B's are going to be B and B bar. And our biforms, so B, this is the only term with B in it, so we're just going to go factor out the B and we get just identity. Do you guys get that? If you remove the B from B, you get identity. You don't get 0, you get identity. I guess I can't really give a very rigorous explanation as to why because I don't quite understand it. And for B bar, the only element that contains B bar is this B bar C, and if we factor out the B bar, it's just going to be C. Now the new consensi is just the sum of the products, so we only have 1 and C, and 1 times C, or 1 and C is just C, right? And then our final set is just going to be the simplification of the union of the initial set and the new consensi. So it's going to be B and B bar C and C bar A and C. And we can just simplify this out. Let's see. Let's move this term over here. So we have B plus C bar A plus B bar C plus C. And I'm just going to say I'm going to use the absorptive law. Or I'll just do it out in long because I hate skipping steps. We got B plus C bar A plus C with B bar plus 1. That goes to identity. And we get B plus C bar A plus C. Okay, so that's going to be our final set here. B, C bar A and C, and that becomes our initial set for the next step. So we have B, C bar A and C, and finally we have our last biform, which is going to be C and C bar, and we just go through this. The only element with just C in it, is this C term here, and C with C factored out is just going to be 1. And the only element with C bar in it is going to be the C bar A term, and we factor out C bar and we get A. And the products are just 1 times A is just A. Okay. So we'll finish this off by doing the union of B, C bar, A, and C, and A. And we just simplify this algebraically, and we get B, or let's see, yeah, I'll move this term over here, and I get B plus C bar A plus A plus C. Yeah, that's right. Wait, what am I doing? Have I messed up? Let's just keep going. B plus A. Oh yeah, that's right. That's it. Plus C. I was doing the right thing. I was just thinking too far ahead. And then let me see here. This reduces down to identity because it's the OR operator, and we get A plus B plus C. And we write down our final set A, B, C. And we took a look at our final set, and we see that there's no more biform, so there's no variable and its complement in it. So that means we're done. So we can say that from the generalized consensus method, if our top event equals A, B, C, and or B plus B bar C plus C bar A, this equals A plus B plus C Q E D. Smiley face. So that's all for the little tutorial. It's a different solution than Dr. Keshava's solution, but I think it's the right one, or not right, but it's like, they both arrive at the same answer. But this makes sense to me. I don't quite understand his trick at all. I mean, the book itself says quite clearly that the final set of terms from step 1 is the union of the initial set and the set of new consensi. So that's what it says. So that's what I did. So if you have any questions, ask me or something. Thanks.